Okay, so I have scraped off the label using either a scraper or a sharp knife there. Clamp it in a vise. That seemed to help out. Yes, that is my furnace running in the background in spite of what I said earlier in the video. However, this tank has been outside for like a year and it's got a hole drilled in it. So as another test, as I mentioned earlier, you can wear gloves and safety glasses, and a face shield is preferred, and stick a flat blade screwdriver down there and depress the valve. So if you get a psh or anything at all comes out, you're not ready to work on the tank. Because a lot of times, depending on the size tank, I cut it in half with a chop saw. Plus you're going to be welding on it, so you can't have any propane in there. It's got to be air, and just air. Otherwise, you know, you could get an explosion on your hands, which we're trying to avoid here. So sometimes if you have the right tire valve remover, you can unscrew the valve out of there, but it needs to be longer than this one. This is about ½ an inch. Probably needs to be in the 3/4 inch long range, but that's not necessary. I'll show more about that later. And the first thing you need to do is figure out the orientation of your tank. Is it going to be flat, or is it going to be straight up, or something else? You know, figure all that out ahead of time, and then you'll know where to drill holes and all that other fun stuff. So a little bit of a process here, but in the end you do end up with a half decent gas tank, especially if it's for an old engine that you can't buy one for. So it does work, but just be careful and patient. And when drilling the little 1/8" vent hole, and to guarantee that the tank is empty, I use a battery drill, and I go very slowly to not generate heat. So that's the thing. When you're getting close to breaking through, just stop and let it cool down, and then proceed to drill on through. And while you're doing that, you want to be wearing gloves and a face shield, just in case you get any propane liquid or anything sprays in your face. You want to be very careful. But once you've drilled through and nothing has come out, just, you know, like say, let the tank vent more, and you'll be good. I'd give it, let's say, a day after you drill a hole to vent, and after that you can cut and hack on it all you like. Using a hacksaw, of course, will be better than zip disc or something, but once the propane's vented, it's just a piece of steel then, so you're good to go. So just to show you the tank construction here, I've got the bottom. I just did a light hacksaw in it there. It's a very thin material, and stuck a screwdriver in, pried it around, and pried it up, and it appears that I put a couple little dings in the bottom there, but in the process of peeling, but it comes across easy. You just got to be careful because it's very sharp sheet metal. So I've kind of changed directions here. I've given up on using the large green colored, I don't know, I guess you'd call them like fatty tanks, versus the taller slim ones. I'm sticking with the slim one since I've done a tank out of that before. The reason is the larger one, it seems to dent very easily. From the looks of it, I haven't mic'd it, but it looks like the two are the same wall thickness. You see, there's I think that's maybe a filler tube that comes in. I just leave that in place. Same thing on this one. Pretty difficult to remove that. But, because this one isn't as wide of diameter, it's stiffer in a sense. Even though metal thickness is the same, it results in stiffer. I also had some problems removing the bottom off it there. Peeling it off, and that be a little difficult. I'll grind some of the rest of it, but since the material is thin, you have to you know, make sure you don't remove any of the original metal if you can. So kind of a change of plans there. So my tank's going like this basically. So that'll be it. I still have some work to do here, figuring out how I want to do the fill pipe. Got the bottom here. I've drilled a 1/4 inch hole through it and put in a piece of 1/4 inch gas line, brake line, whatever you want there, and I'm just going to braze it into position. Haven't cleaned it all up yet, but I'll do that later on. I'm holding it here with vice grips in a vise, trying to minimize my heat loss, hoping my MAP gas powered brazing torch will have the fruit punch to braze it. So here I'm drilling out the this end of the tank to 1/2 inch. I drilled 1/4 and then 3/8. Now I'm going 1/2 inch. It's tricky going though. You can't clamp it in the vise very hard, or you'll collapse the wall. So it tends to slide around and things, but eventually I will get it drilled out to 1/2 inch there, so that gasoline will flow into the tank not too bad. So I got it drilled out to 1/2 inch there on the inside, and I believe this is a pressure relief valve. Not really 100% sure, but I'm going to weld it shut. Now for the lid, or the filler hole, I mean, I'm going to take a 1/2 inch washer, and this is a half of a 1.5 inch, I guess you call it a union, and then 1 inch pipe plug. So that's what I'm going to use there. So hopefully that'll work out. So I drilled the 1/2 inch washer out to 3/4 inch inside. Suppose a person could use a 3/4 washer, but I didn't have any. The idea here is to weld it to the top like that, and then weld half of my union there to that. It'll make it easier to weld this way. I'm welding to thick metal here versus the thin wall of the tank, so that'll hopefully make things stronger in the end and easier to weld. Well, I have it welded up here with the washer on first, and then welded it on there without this being on, and then welded the half the union on there. So I'm going to leak test it with gasoline once it's all cooled down here. It's pretty cool now. And as you can see, I brazed the 1/4 inch stub into the bottom there. Just to give you an idea, it'd be better to clean this up first. I had some problems with the second layer of metal peeling apart there while I was brazing, so you have to reform it circular again so the two will mate up. And I also welded over this, I believe that's a pressure relief vent, because it works opposite to a regular tire valve. And then of course my plug just screws in the hole there. I had it screwed in while I was welding, just to make sure that no weld spatter could get in the threads. So I'll leak test this, and then it'll be time to weld the tank together. Well, I managed to weld the bottom on the tank there. I'm sure you professional welders will laugh at this job, but it's using flux core rod, and basically had to pretty much spot weld it because it burnt through a few times. But I also managed to collapse the tank wall with my vise here, even though I wasn't twisting it down very hard. As I say, this is due to the thinness of the steel involved here, it's pretty hard to work with. Now if you had a TIG welder, or even gas MIG welder, I'm sure it would work better than this, but like I say, flux core, it does the job. But that's about all I'll say about that. So now it's time for another leak test there to see if my weld will keep the gasoline in the tank. Gotta let the tank cool off first, of course, but don't want any explosions on our hands here. So here's my pretty well completed gas tank. I still have some work to do on the bracket there to mount it to the Briggs engine, but see, I drilled a 3/64 hole in the cap there for a vent, and I've also ground the threads down so the gas won't wick its way up when the engine's shaking around. And here's what I started out with, just a regular 1-inch pipe plug and a 1-inch coupling. As I say, I cut the coupling in half so you could actually make 2 of them out of it. But and the other thing I wanted to point out, don't drill any larger than a 1/2-inch hole through the top of the tank. I'd even maybe go 7/16 because the wall starts getting a little thin. So that's why I've welded these 4 or 5 little kind of braces there to it. See, I can weld it over the I think it's the fill part of the tank. I'm sure professional welders will be laughing at my welding job here, but it is flux core, so it like to burn through. So it should work for my purposes. As I say, most of these engines don't run very long, but if you build the tank good and solid, and see, I kind of tack welded the tank to the bracket there. Lots of different places, and got about 1-inch long weld each end there. You got to make it so that there's no danger of your tank breaking free from your mounts. Engines shake, vibrate and things, so you have to make sure that you know, your tank's securely mounted. You don't want it breaking off and a piece coming out and spilling gas all over a nice hot engine, starting a big fire or explosion. That wouldn't be a good thing. So I'll show you an example of a couple more tanks that also. So here's an earlier gas tank that my friend at AC/DC Welding made for me there. I gave him the pieces and he did the rest. It works fine on the 2-cylinder and on the 3-cylinder stacker engines there. See a little vent in the top there. Looks like 3/64 diameter. But the thing I wanted to mainly mention here was the mounting brackets. You have to figure out good solid mounting brackets, and you have to have good welds to the tank because engines vibrate, and you wouldn't want the side of your tank to crack out and leak gas all over and start a big fire, and you know, it wouldn't be a good thing. So you have to figure out good mounting brackets. For horizontal tanks, here's some stock older cast iron block Briggs tanks there. I see somebody did a custom job on the tank cap on this one. Looks like a piece of brass pipe or something there, fine thread on it. But those tanks are held in place by straps, so I would think a person could butcher something up out of strap type hose clamps if you had to, especially on a horizontal tank. As you can see here, I've chosen to weld mine, but I don't see any reason why straps wouldn't work. But you have to have it securely mounted, and once again, think about the vibration and fatigue that is caused by the engine running. So you don't want, like I say, a sidewall coming out of your gas tank, leaking gas and starting a fire. Wouldn't be a good thing.